So today we'll be looking at fire underinsurance and policy prescriptions for this. So starting with the ground with the idea that there's increasing risk. So a paper by Westerling and paper by Canadell, they both cite increasing risk because of a combination of severity and because fire seasons are extending deeper into the year. And as you can see in all these figures, even though frequency of fires remains relatively stable, if we looked at burned area, that has gone up in recent years, indicating higher severity and as such higher risk. So now to look at generalized reasons for underinsurance, Kunrather, he cites underestimated losses and underestimated probabilities in his underinsurance framework paper. And these are just generalized reasons for underinsurance across broad insurance markets. Latham, looking more specifically at fire insurance, he cites the expectation that the government will step in and cover costs in the event of a disaster as a reason for underinsurance. So he looks at that. And according to a paper by Tranter, affordability can also be an issue. If we look at table one on the right here, we see that underinsurance is a thing. If we look specifically for fire underinsurance, if we look at the bushfires in 2009 in Queensland, we see that insurance claims were significantly lower than losses, indicating underinsurance. And we'll be looking at three frameworks in this presentation for underinsurance and attempting to address those with the policy prescription. One is probability miscalculation, two is underestimated losses, and the third are extreme versions of the first two. So expected government intervention is one way of underestimated losses, and probability zero is an extreme version of probability miscalculation. So we'll be looking at those as well. So some behavioral economic foundation for the three. For the first one, overconfidence and myopia are reasons for probability miscalculation. So overconfidence will refer to the ability to properly estimate average risk, but believing personal risk is lower. So you're underestimating probability. And myopia refers to underestimating average risk and as such personal risk as well. And so that is, both of those lead to probability miscalculation. Also experience bias. If you haven't experienced these negative events, you're more likely to underestimate the probability of these events occurring. For the second one, underestimated losses, framing effects, and the framing effect framework developed by Tversky and Kahneman is really insightful into that. So depending on how natural disasters, and in this case fires, have been framed throughout your life, that might impact what you perceive losses. If you're constantly watching on the news massive wildfires, you probably won't underestimate losses. But if fires are generally shown just a small kitchen fire and that's all your exposure you have, you will underestimate losses. Third, expected government intervention and probability zero. Exposure is, again, very insightful into this one, as if you've never been exposed to the risk, you'll calculate probability zero. And also heuristics is insightful into looking at this third framework. So moving on to the economic framework we'll use to analyze underinsurance, we'll be using expected utility theory as well as prospect theory. So expected utility theory is the most basic analytical framework when looking at risk. And it basically says, I will maximize expected utility given probabilities and payoffs. Prospect theory is a behavioral spin on this, in where you have both probability weighting functions, which weigh your perceived probabilities, and value functions, which weigh your payoffs. And so for our frameworks, we'll be particularly focusing on the probability weighting functions. And a very insightful one will be the composite probability weighting function. So this one underestimates and underweighs low probabilities, very low probabilities, and overweighs very high probabilities. And so what you get in this particular case, when we're looking at fire are low probability events, very low probability events, but with significant downside. So it lies in this area of the curve where you'll underestimate and you'll underweigh probabilities. We'll make three assumptions for our frameworks. One is a boundedly rational agent, two is an actuarially fair premium, and three is a risk-averse agent. For boundedly rational, this simply means that the reason the agent's not behaving optimally is just because of behavioral biases. And within the behavioral framework, they are showing some optimality. So looking at our first framework, probability miscalculation. This is based, as mentioned, on the probability weighting functions. And so as we can see down here, perceived probability of the good outcome is greater, and perceived probability of the bad outcome is less than the true actual probability. What this results is a shift in the expected utility curves from the blue curves to the red curves. And what happens is when you optimize your insurance choice under perceived probabilities, you'll be at this point denoted by the arrow. And what you'll get there is when you optimize based on true probabilities, you'll be at this point denoted by this other arrow. And what you see is actual expected utility based on true probabilities will be lower if you pick insurance based on your perceived probabilities. And as such, you'll have a case of underinsurance. And the maths showing that are right here on the left. So for framework 2, this is underestimated losses. So what this does is this changes the payoffs. And so what you get is you move from, you can see that the shape of the expected utility curves remain the same because probabilities remain constant, but you'll move from the blue curve, which is the true lottery right there, to the pink curve, which is the perceived lottery. And if you were to optimize given the insurance constraint, you'd be on the green curve, which is lower than the pink curve. So your perceived expected utility is higher if you don't insure, because insuring would move you to a lower curve when you move to the certainty point. And so you won't insure. And here's again, the maths for this particular case. For our third framework is probability zero and government intervention. Government intervention is just a different way to approach underestimated losses. In this case, you do expect the loss correctly, but you expect the government to compensate you in the event of a bad outcome. So what you get is you move from the original lottery, which will be right there, to the perceived lottery. Again, you get the same issue that your perceived expected utility is higher than your expected utility if you were to insure, so you won't insure. And probability zero just moves your lottery vertically up to the certainty line, which will be on this pink curve. And you get the exact same issue, exact same mechanism, because your perceived expected utility is higher than what your expected utility will be if you insure, you'll go with no insurance. So for a proposed solution, we want to model it on the National Flood Insurance Program, which mandates that all mortgaged houses in the United States within certain high-risk areas, they have to get flood insurance per federal regulations. This has been really effective. One principal concern with underinsurance is that the government has to pick up the bill. And when we look at FEMA and the amount of money FEMA is paying, only 20 to 25% of FEMA assistance is directed towards households within the National Flood Insurance Program. So it's showing effect in that sense. So what do we propose? Australia does not have a program like this. So and fire insurance is done privately. So we propose that households in these high-risk areas also get mandated to take up fire insurance. And so as such, they'll be sort of moved to being on the insured curve. And as cited, Colshaw and Turner, they argue in favor of mandatory insurance as it is effective in maximizing the risk community. So what effect would this mandatory insurance have if it were to be replicated in a place like Australia? So what it do for framework 1, the idea would be that it fixed the behavioral biases and scrapped the probability weighing functions, that people would actually have to think about insurance. But that's not necessarily guaranteed, but that's the idea behind it. What it does address is framework 2 and 3, when you're on higher expected utility curves, given your perceived losses and perceived and probability zero. What it does is it legally does not allow you to perceive this as the highest you can possibly, since you have to insure, you have to maximize given the insurance line. And because your probabilities are correctly forecasted, you will be at optimal insurance as shown on the graph. So that it will lead to optimal insurance. And finally, here are my citations.